Continuing once again the First Global Revolution, we are in Chapter 9, Agents of the Resolute, and this is Part 4. Technological transfer has often proved to be a failure, either because of insufficient experience in the importing country in the selection of technologies appropriate to its needs and traditions, lack of negotiating skill, or absence of sufficient technological and managerial experience. The newly industrialized countries of Southeast Asia have succeeded in their development by following the post-war path of Japan and concentrating initially on building up the educational system, establishing modern research and development institutes, and then importing carefully selected processes. The larger developing countries also have already built up a sufficient capacity in science and technology so as to be able to select with confidence technologies from abroad, tailored to their needs, and to undertake original innovation. The challenges thrown up by the turbulence of the global revolution indicate the need for a substantial reorientation of research and development programs and a radical reordering of priorities. This is not the place to put forward detailed proposals, even should we be capable of doing so. Nevertheless, it may be useful to suggest some broad lines of approach. Fundamental research. As argued above, effort should be put into investigations concerning the human individual, his nature, motivations, potentialities, and limitations, as well as into the social, educational, and other structures which project human qualities and defects. There should be encouragement of fundamental research in the developing countries and the provision of adequate facilities for the upgrading of the knowledge of scientists from the South, such as those as Abdus Salam's International Center for Theoretical Physics in Trieste. Research on the operation of the natural system of the planet. We know all too little about the tolerances of the system and of its reactions to human impacts. Sophisticated models of the global climate system have shown its extreme complexity and the need for still more detailed knowledge concerning regional and local impacts of human activity, greatly necessary if we are to foresee the consequences of earth warming and the other macro pollutions. There are great gaps of knowledge, for instance, concerning the sinks for carbon dioxide. It is said that only between a third and a half of the emitted gas can be accounted for. There are vast zones of ignorance which must be closed if we are to learn sufficiently about the tolerance of the system before we destroy it and ourselves through ignorance. Research leading to technological innovations. Such research aimed at solving or alleviating many contemporary problems will be both remedial and preventative. We shall outline here a few of the most obvious lines of attack. As already stressed, there is an immediate need for a massive campaign on energy conservation and efficiency. On the conservation side, the requirement is more for the application of well-understood techniques than for research. However, to be successful, there will have to be considerable changes in human habits, and this will entail new activities of the social sciences. There is, however, great scope for research aimed at improving efficiency in the next generation, transmission and utilization of energy, for example, by the use of superconductivity in the design of new types of engines, in machines of a wide variety of types, and in chemical manufacture. Techniques of energy accounting need to be developed and applied, while the bulk of these efforts will have to be made in the countries of the North with their energy-intensive economies. The South, with its increasing populations, will face the same needs. It is encouraging to note the recognition of this in the recent Nairobi Declaration on Climate Change, May 1990. Second, it will be necessary to give a very high priority to an international program of research for alternative energy sources and for corresponding work in the individual countries. This should include nuclear fusion development, magnetohydrodynamics, and the whole range of soft energies. Work should be also accelerated on the possibilities of a future hydrogen economy, the gas being produced by the decomposition of water by electrolytic or catalytic means. This is not an alternative energy, but an energy transmission method for use as a fuel in automobiles, aircraft, etc. if oil becomes costly or is discouraged for earth-warming reasons. Beyond this, a search must be made for new clean technologies and for the cleaning up of traditional processes. In the chemical industry, for example, research might be directed towards finding more specific synthetic routes, including research on new catalysts. In this industry, research must also be aimed at making toxic wastes harmless and doing so with minimum energy expenditure. Here, as in other industries, research on recycling techniques is required. A further task for the chemical industry is to devise biodegradable plastics for packaging and other purposes. In agriculture and the agro-industries, a determined effort is called to reduce energy use. Much useful research is already in progress for breeding non-leguminous cereals capable of fixing their own nitrogen and hence to reduce nitrogenous fertilizer use. More work is required to replace chemical pesticides by biological control systems. It is urgent also to intensify genetic breeding to provide basic cereal crops with greater resistance to insect and fungal damage and also to various possible changes of climate. In the field of transportation, much interesting work is in progress, and in view of the desirability of encouraging communal traveling, new flexible systems of urban transportation are urgently required. And I'll stop it here, and we'll pick up with Chapter 9, Part 5 in the next video. This was the end of Part 4.